Have you ever wondered how the thousands of satellites orbiting Earth manage to avoid crashing into each other? It's a marvel of engineering and coordination, often referred to as space traffic management. While space is incredibly vast, the orbital paths around Earth are becoming increasingly crowded, especially in low Earth orbit, where many communication and observation satellites reside. So, how do we prevent a cosmic pileup? It starts with meticulous tracking. Various agencies around the world, like the US Space Surveillance Network, constantly monitor objects in space, from active satellites to tiny pieces of space debris. They track anything roughly the size of a softball in low Earth orbit and larger objects in higher orbits. This tracking data is crucial for predicting potential close encounters. When a potential collision is identified, satellite operators receive what are called conjunction data messages, or CDMIS. These messages alert them to the probable timing and proximity of a threatening object. This is where the magic of collision avoidance maneuvers comes in. Satellites with onboard propulsion systems can fire their thrusters to slightly alter their orbit, moving them out of harm's way. This isn't a last-minute swerve. These maneuvers are carefully planned hours or even days in advance to ensure the satellite safely clears the predicted collision path and doesn't inadvertently create a new risk. For smaller satellites, or those without propulsion, other methods exist, like using aerodynamic drag in lower orbits to make slight adjustments. The goal is to minimize collision risk and then return the spacecraft to its original orbit once the danger has passed. It's a continuous, dynamic process that relies on a global network of sensors, sophisticated analysis tools, and increasing automation. While space is big, the growing number of satellites and the ever-present threat of space debris mean that effective space traffic management is more critical than ever to ensure the continued safe operation of our vital orbital infrastructure.